Hey everybody, this is Kite Altera here, and in this video I'm going to be doing a review for the JB Tech 8-channel 5-volt relay. So without further ado, let's go ahead and get to the module and we'll go from there. Alrighty guys, so here's the 8-channel relay that I got off of Amazon. As you can see, I already got this wire spliced in for an experiment I'm going to show you guys. It's going to be connected, it is actually connected to a grow light that I use for my gardening. This is just a sample, and as you can see here, I have my Elegoo, which is a microcontroller that is similar to the Arduino. It's not a knockoff version per se because it doesn't pretend to be Arduino, but it's just a microcontroller that's a cheaper version than the Arduino. So the first thing I noticed when I connected this, if you look really closely, it's actually a bit of rust on it. So let's see if we can get a close up of this. Yeah. So if you look closer to this, you can see there's definitely some significant rust on this. Was not too happy when I opened it up and saw this. I thought it may be some type of oil, so I tried scratching at it a little bit with a pin, as well as just a metallic object, but it's definitely rust. So that tells me that this has probably been sitting here for quite a while in storage. I don't know for certain, but I definitely know that these relays should definitely not be sent to a customer like this. So how this would work, let's take off this focus now. So how this works is you would get either a flathead or a Phillips head, and you would go ahead and you would insert the screw, you would insert the actual flathead or the Phillips head inside of these. And once you take them out, you can go ahead and get the wire that you spliced into it, take this out, and then you would put it against it and you would tighten it. I didn't have any problems really getting this on or off, but one thing you need to note is this illustration. So the middle pin on each of these relays is the common. So you want to make sure that you find out which wire is the ground and put one side of the wire into the center of the relay, which is your common ground. And if you go to the left, that would be your normally open, and if you go to the right, that's your normally closed. So once I was able to figure out the ground, another thing you need to make sure you do is look closely at these the wording here, because it actually has a tolerance range. So if you look here, it'll say it has a maximum tolerance of 10 amps, and it can take a maximum of 30 volts DC and 250 volts AC. So if you want to make sure that you have the right voltage, what you need to do is some quick math. So I'll show you the math right now. Alrighty guys, so really quickly I went ahead and drew this illustration for you guys. This is the easiest way I've been able to find online of how to determine what the voltage, amps, and wattage would be. So if you see it like a triangle as seen here, if you're trying to find the wattage, you would just multiply the voltage by the amps or the amps by the voltage, either or, it doesn't matter, you would still get the wattage. If you're trying to find what the amps are, you would divide watts by voltage. If you're trying to find the voltage, you would divide the watts by the amperage. Now, normally when you look on the side of a product, they will have the optimal voltage as well as the watts if you're using something like a grow light, which I'm using in this video, or something like a heat lamp, which I am going to be using in a different video and a different application. So because they normally give you the voltage and the watts, you need to find the amps, which it'll be easy, just divide watts by voltage, and then I'll give you the amps. So then if you compare the number that you get with the maximum amperage allowed on this relay, that would tell you that if it's above 10 amps, you cannot use it, but if it's below 10 amps, then you are good to go. One thing I would like to note is that if you're going to be using something that's close to 10 amps, to please ensure that it's not exactly at 10 amps, because when you power something on, it may have a jump that's slightly above the 10 amps. And the closer you get to that maximum, the higher the likelihood that you will damage the product. So I would implore you guys to please ensure that you do not use something that's exactly 10 amps. If you need to use a relay that has a higher tolerance, make sure you just look online, because they have plenty of DC relays that are solid state that you can use, and that way you can ensure you have the product and you have your mechanism however you want it lined up without risking a fire or electrical damage or anything like that. Alrighty guys, so I finally got the Elegoo connected to the relay with all the relays. Every single relay is connected to the Arduino and is able to turn it on or off. Now, first thing I'd like to mention is you can have these relays externally powered by removing this jumper. Make sure that if you're going to connect this jumper, by the way, that you have JDVCC connected to VCC and not to ground, or you're going to short the whole thing out and buy a new board. So make sure that jumper is on JDVCC and VCC, and ground, the ground pin is not touched at all. You can connect this externally if you get I believe it's a 5-volt power source. Don't quote me on it. Plug it in, splice the wires into it with some jumpers, and then connect it to a power strip or the plug directly, and then you'll have it isolated. But for me, since this is just for experimentation, I am not going to have it externally powered, so I'll just keep that jumper right on there. So without further ado, I'm going to do the power on self-test for it, and we'll just go from there. So I'm going to plug in the USB, and I already have the code uploaded to the Elegoo, so it'll just start automatically. And it'll just keep cycling like that until I stop it. So what this does is verifies that each relay is working, and you can hear the little clicks for each every time it's turned on and off. And this sound is not that big a deal. It's not really bothersome. Now, if you have it constantly turning on and off, then it can be annoying, but I'm just showing you this for demonstration purposes only. So I'm going to go ahead and disconnect the USB to turn this off. And there we go. So now it's off. Now, the next step is to actually show you guys it in operation. So without further ado, let's go ahead and jump into that last part of this video. Alrighty guys, so for this last bit of experimentation, we have this grow light connected to this relay, as you can see here. If you follow it around and we go down a little bit, you can actually see where it is connected, spliced into this relay via ground. And I also accidentally cut the VCC wire. That was by accident. I thought I had to put both in at first, but once I realized the mistake, all I did is got some soldering wire and reconnected them, and then put a lot of electrical tape around it to verify safety. And that was about it. Make sure, like I said before, that you're connecting the ground to the side. And what I simply did to verify it is looked it up online to see which plug, since one plug always looks different from the other, which plug shape was ground and which one was VCC. Once I was able to verify that, all I had to do was just follow the wire from the plug, and it was a done deal. So we're going to go ahead and pan up slightly, and we're going to keep it right there. So in this next experiment, I'm going to go ahead and plug in the USB again. I already changed the code and uploaded it to my Elegoo, and you guys will see how it works. So it's already uploaded. Plug it in. Okay. And there you go. We have power. So you can adjust the code to adjust the timing on the Elegoo, or in this case, it's the actual Arduino interface. So I made sure that I identified what the actual lead was, where it was located, how long I wanted it on and off. So this is just on a simple cycle. And I'll just keep it going for probably one more go. And yeah, it doesn't take a whole lot. You just got to make sure you know exactly what you're doing and carefully plan for it. So here's the experiment. It definitely works. So I'm going to disconnect the USB and we'll go into final thoughts. Okay. Now that's done. Hurry up because I don't have a whole lot of battery left in this. All right, 3, 2, 1. Hold on. All right, 3, 2, 1. Alrighty, guys. So that is the full review of the JB Tech 8-channel 5-volt relay module. Overall, I'm pleased with its operation. I didn't have any hiccups, any issues whatsoever. And if I did, it was because of me and not because of the component itself. However, I do have to knock off significant points due to the fact that I was given a product and shipped a product that had rust over 80% of it. Most of the leads that you put the wires into were rusted. Beyond that, though, it works how it's supposed to. I'm just really not pleased with the rust that was on it. So would I recommend it? Definitely, I would recommend it. I would ensure that you return the product if you have rust on it. But since this is just for experimentation for me, I'm probably not going to return it. It's not worth the wait because I have other projects that I need to get on stat. So because of that, it is what it is. But that's definitely some points knocked off for JB Tech for shipping a damaged product. So without further ado, this is Kite Altera here. Thanks for watching my review video. Please like, subscribe, share with your friends, as well as hit the bell icon next to the subscribe button so you can receive daily alerts for when I post a new video. So that's all for now. I hope you guys have a very blessed day and a nice weekend, and I will see you next time. Bye.